Hello, my name is Ilker Boz. I'm a research scientist at Virginia Transportation Research Council, a research division of Virginia Department of Transportation. In this presentation, I'm going to cover a test method that evaluates the rutting potential of asphalt mixtures. This test is not a requirement at the moment for Virginia Department of Transportation's BMD spec, but the research still undergoing at VTRC evaluated the simple and practical test for rutting evaluation of asphalt mixtures, because APA is not a practical test, especially for production level testing to determine the rutting potential of asphalt mixtures. There is no standard available for this test yet. However, this test resembles to a cracking test in so many ways. So I modified that standard to reflect this test here. The scope of this test is cover procedures for preparing, testing, and measuring asphalt mixture rutting resistance and determination of indirect tensile strength. Again, this is very similar to cracking test as well as TSR test. Uses the same equipment, same specimen size, except for TSR, the differences in specimen conditioning and also the calculating the parameter of interest. This test method is intended to determine the rutting potential of asphalt mixtures. The higher the strength, better the rutting resistance. This test method will be incorporated into VDOT BMD specification as an alternative option for rutting evaluation, an alternative to APA. So spec will have APA test as well as this test, and I'll cover in a next presentation ideal RT test that would be also listed there as an alternative option for rutting evaluation. Same apparatus needed for cracking test is needed for this one, except that maybe your conditioning environment has to maintain temperature of 54.4 Celsius degree. Other than that, the rest is the same as the cracking test. Again, same as cracking test, two types of specimens needed for this test: laboratory mixed and laboratory compacted, which is a design stage, and field mixed and laboratory compacted, which is a production stage testing. And in this instance, we require only 3 replicas to be tested under this test, with air void requirement of 7 plus minus 0.5%, and diameter and height same as the cracking test, which is 150 millimeter diameter and 62 millimeter tall specimens needed for this testing. A laboratory mixed and laboratory compacted specimens require short-term aging on the loose mix for 2 hours at the design compaction temperature prior to compacting. This is the same requirement for APA. And then compact 3 specimens to a height of 62 millimeter and air void of 7 plus minus 0.5%. The difference here from APA procedure is that in APA, specimens are compacted to 75 millimeter tall. In this case, it's 62 millimeter tall, which is the exact height of the cracking test. So it creates a convenience for lab technicians to compact all their specimens to the same height. And before testing, specimens have to be conditioned at 54.4 C for 2 hours. And I have to add the caveat in here: the conditioning environment has to be at that temperature when you place your specimens, and 2 hours starts from that point forward. For field mix and laboratory compacted specimens, for short-term aging, you minimize any cooling of the loose mix and bring it to compaction temperature immediately, and then compact to the air void and specimen size requirements. Again, you have to condition your specimens at 54.4 C for 2 hours. Testing procedure, as for other tests, TSR and IDT-CT, you are going to inspect your fixture to ensure that all surfaces are clean and free of debris, and then make sure that specimens are installed and ensuring they are centered and making uniform contact on support. And then the loading rate is the same as the cracking test, 50 plus minus 2 millimeter per minute, and then load drops to 0.1 kilonewton. So you could use the settings that you use for CT index test for this test as well. The testing shall be completed in 2 minutes or less for this test after removing it from the conditioning environment. Please note that the temperature is higher in there, so cooling rate would be faster. So if you fail to meet that time requirement in there, you are going to get false positive results, because when temperature cools down, your strength will go high for this testing. So that's important that you strictly stick to that 2 millimeter or less time duration. Data quality checks, I'm not going to go over again on this one. Please refer to the IDT-CT test procedure or presentation, because it's basically the same test and same rules apply here. Again, I'm just going to go over these here. Unit issue here, and load is not dropping to 0.1 kilonewton. Some sort of glitch and range issues here with the LVDTs. And then synchronization issue with the data. You don't want to have all of these. And then once you have your test completed and data quality checks are done, then you're going to determine the peak load from the load versus displacement curve for this one. And then you would know your specimen thickness and diameter and plug the numbers into this equation. You would realize that that's a strength equation that you use for your TSR testing. And then the IDT strength criteria for this test is 133 kilopascal. Please make sure to pay attention to the units here. And then if you have a strength that is less than that value, you are failing to meet the requirement. If you are exceeding that value, you have the mixture that is resistant to rotting. We don't have precision estimates and statements developed for this test yet, so research is underway to cover that one. And with that, I conclude my presentation. Thank you for listening. Please email me your questions if you have any questions at ilker.baz@vdot.virginia.gov.